Hi, I'm Pakera12 and today we play a little bit different. Today we'll attempt to do something that usually requires code, and let's have a look here on ShaderToy. This is the default file. Each time you choose a new one here, you get this nice ramp colors, and this is the code. And I want to recreate this in Touch Designer. So I have the code here, and let's have a look. We need vec2, and we'll get vec4 out, which in this case it's color and alpha. Okay, actually we need to build the UV first, and we'll go with square resolution for this tutorial. So let's grab a constant chop. Okay, and what we need the resolution. So 1024 is good for now, and let's have a ramp. Okay, and this one should be 32 mono, and the resolution, let's have it from here. We need a reorder. Okay, and flip. Okay, and here in a flip we flop bottom left. Okay, here we take the input 2 and we say this should be 32 RG. Okay, and we have the UV now. Okay, let's see what else we need. Here it's something like we have a number plus multiplication of cosine from 3 items. Okay, so one it's vec3 by definition, the other one is vec3 also. You notice it's our UV xy, and it takes the x for the z. So we do the same reorder, and here we'll take red also for blue, and this should be 32 RGB. We good now. What else? We have iTime and vec3024. Let's have this vec3 with a constant top. Okay, let's set the resolution, and this constant should be a vec3, and so 32 RGB, and the value for RGB will be 2, 0, 2, and 4. Okay, and yeah, we have vec3. So this is vec3024. Okay, and this one is UV of x, y, x. Okay, and we need something similar for iTime, and let's set here iTime, and we can use ABS time dot seconds, right? And let's use a constant. Okay, and we have this, and this should be 32 RGB. Okay, now it's a cosine of those 3 added together. So we use a constant top, since the add here it only takes 2 inputs, and we have 3. Okay, not constant, sorry, composite. Okay, and okay, and this here we take add. Okay, now we need the cosine of this, so we use function, and here we take cosine. Okay, and instead of degrees we go with radians. Okay, and what we need now is a math, and we multiply with 0.5 and then we add 0.5. Okay, and let's put a null here, and this is the default file in Shadowtoy done with tops. Okay, and I will select all of this and collapse selected. Okay, let's name this default. Okay, and now I would like to take another example of a little code in GLSL and try to make it again in tops. And for this I will go here and we'll try to implement the simplest SDF function of all, the one for the circle. Okay, so let's take this code. Okay, and here if okay, but we copy this and SDF, this one is SDF, we only need the UV here. Okay, and now we need this code to be this one. Okay, and let's, okay, so we have a distance, a float, and a vec2 p, which would be this UV positions, and a radius, and then we need to find out the length of the p and minus the radius. Okay, and here let's go here with the radius. Okay, and 0.325. Okay, and first let's find the length of this vec2 position with a math, and here we go for square add root mask alpha, and this has to be 32 mono. Okay, the reason we have the 0 center in the corner is because we need a mod here, and we rearrange this to minus 0.5 and 0.5. Okay, and now we need a texture, a similar one with the radius, and let's grab a constant. Okay, this one is mono, this one should be the same, so it's 32 mono, and it has this value for radius. Okay, and now if I use subtract, okay, and yeah, it's hard to see now, but if I use a mod, I can say here either ceiling, and then I have the outside points of the circle, or I multiply here with -1 and I have inside points. And what you can do with this, yeah, let's grab another ramp. We have one here. Okay, so Control C, Control V on this one. Okay, and now if I remap this over this here, and now I'll change the period of my ramp, so now I can have the ISO line marked with those ramps. Okay, or I can color the steps if I make them. So right now this texture has a smooth ramp, and if I use a matte, okay, and yeah, let's say I multiply by 32. Okay, and here I go for ceiling, and now a matte again, and instead I'll grab this value for the multiplication to the other one and use it as 1 divided by. Okay, now I have if you see, I have some steppy ramp. Okay, and yeah, let's see why we have a small resolution, because of this constant. Okay, it has to be like this. Okay, so this, or it can look like this, or even better if we use a noise, again the same resolution. Okay, and let's have this color. Okay, and yeah, this is how you play with SDF of circle. And if we look here on 3D SDFs, we notice the function, it's the same. Okay, and since we already have it, it would be nice to see this in 3D, right? And I want to thank you for all the nice feedback I got from the previous tutorial, and I'll give you this method as a bonus. And I was thinking, okay, how can we make use of the SDFs for the same 3D textures that we fake in order to fill a cube. Okay, let's do this. Okay, so I will copy again this one, and I say 3D here, and let's go inside. So what we need, let's delete those. We don't need them. Okay, and with this rule, with this function, we can find the distance from each point in this UV to the center. And if we build an UV in a cube, like in a previous tutorial, then we can try to see if we can have a sphere in a 3D. Okay, so first let's have some little changes here, since we will need the cells. Okay, So for the resolution we need resolution of a cell, so we go with 10, and remember we use a ramp initially by 10 and 1 pixel. Okay, and I would like to have everything here nearest pixels here, since I like to see what I'm doing. So instead of this ramp we need a fit now, and this fit will take no, sorry. Okay, and okay, we need fill here, right? And now we have the UV. Okay, again we need something like let's select the resolution here and rename it map. Okay, and with a mod, let's see the root and ceiling, and now we need a merge. Okay, null again here. And would be nice to take the values out of here. So okay, and where else? Here we need for this maybe. Okay, and yeah, for the radius also. Okay, now we would like to have slices of this. Okay, so let's grab select. Okay, and take this, and now we have 10 points. We need 4 by 4, we need 16, so we use group. Okay, and here we'll go with the pixels and take the map and square it. Okay, and now we good. Let's make all the pixels black, so 0, and we go for nearest pixels. Okay, and out of here we take top 2. Okay, and the air we want to shuffle this into a square. Okay, and so we take split end samples and use this map. Okay, and now let's see the texture. Okay, so here we go with the nearest pixel again. Okay, and let's take this, and first we use a transform here. Okay, in which we need to use a bigger texture which contain all the cells. So we need the resolution to be resolution multiply by the map size. So we go with this. Okay, oh sorry, like this, and Control C, multiply, Control V, and let's say here it's map. Okay, Okay. And now we need to scale down by 1 divided by the map. Okay. Okay. And here we also take nearest pixels and tile repeat and 0 0. Okay. Now you notice here I have a lot of circles, and yeah, it's looking promising already, but we don't have the Z yet. So let's do this. Here we use reorder. Okay, and we take the input 2 for the Z, and this should be 32 RGB. Okay, also okay, and now let's use a math here. Okay, this one should be ceiling, nearest pixels, and yeah, I want to isolate the not needed cells, and so I multiply here. Okay. Okay. And yeah, now I have something different, you see. And yeah, first let's use a null here. And what I did here, I have the Z from 0 to 1, and for the cube to be in the middle, we actually need to remap this from 0 to 1 to minus 0, 5, 0, 5. Okay. And let's instance some boxes. So we have some boxes. Okay, this one goes into a transform which takes the res here, 1 divided by, okay, and yeah, let's use now geometry, and here we have the points. Let's see them. Okay, instancing on, and let's see, LG and B. Okay, well, let's split the screen a little bit, and here we go with geometry. Okay, I suppose we need to put a little multiplier for the gaps, would be easy to notice. So I multiply with 0.925. Okay, okay, and let's see if everything is good. It should update the size. It's good. Okay, now let's go with 100. Okay. Now I would like to only see, so a null here. Okay, I will make the scales as here. So I'll take this and R, R, and R, and I believe I need a level maybe. No, wait a minute. Oh, so Oh, okay, so let's check 100. Oh, okay, okay, I got it. So this one, it's good. 100, 100, okay, okay. Yeah, this here, this constant here, this texture should be the resolution as here. So let's take the value and use it again here. Okay, now we don't need, I believe we don't need this level. Yeah, now you see we have a sphere, and if we change the radius, it gets smaller. Okay, and now if we inverse here, where we do this math, okay, if instead of -1 we take 1, we see the whole cube, but with the radius bigger than 0.5, we make these holes in it. So yeah, this is how you make use of SDF functions and use it in Touch Designer. And I will not spend any time on coloring this, since it's already covered in some other tutorials. I really hope you like this one, and yeah, subscribe if you haven't already. Hit the like button, and you can support me on Patreon. There you can get access to some different tutorials I'll have there. Each time I will make a new one here. So the last one is it's about exploring Mandelbrot set, and you can get some nice surfaces like here. In the end, I would like to thank to all my patrons, especially Breckwood, Roy Gerritsen, Gavin Grindon, and Dimitri Diak. Thank you so much, guys, for supporting me. And yeah, see you in the next one. Bye.